Okay, thank you. All right, thank you everybody for being here today. And thanks for, I also want to thank Formnext for the opportunity. We will spend the next 20 minutes on additive manufacturing for SNCF Reseau, and I will try to keep 5 minutes at the end for any questions you may have. A few words on me. I work for SNCF Reseau, of course, in the engineering department, and especially in railway signaling. And I'm head of the technical policy team, and I will come to what we do in a moment, because additive is part of this job, but only a part of this job. Okay, so today my main objective is to share with you what are our stakes in additive, why we need additive, and what we need from the industry to really find solutions to our issues. This will be the first part and main part in what I want to do today. I will then give you a few insights on the technical side of the job, what we do, what we have done, what remains to be done, and then I will try to summarize quickly a single slide, but I think the main takeaway will be in this slide. Okay, the first slide has only one purpose, just to explain that we do not deal with train. I mean, passenger train, freight trains are not in the scope of the infrastructure manager. Usually, when I talk about additive manufacturing for the rail company, people want to talk to me about flame retardancy, like in the previous meeting. I'm not really interested in flame retardancy, because I do not have passenger trains in my scope. Okay, so if we do not deal with the trains, what is our job? So mainly we sell the right to use the network. That's how we have our incomes, something like $8 billion per year, okay, which allows us to maintain, develop, modernize the network. Just to give you an order of magnitude, there is something like 50,000 people in SNCF Reseau, so it's quite a big company. A classic picture, I think everybody has seen it once, at least one time in his life. What is the consistency of the network? Why are we interested in additive? Because we have a lot of different parts. Usually people don't imagine. First of all, we have the railway signaling. Railway signaling is not only about the signals, even if it's in the name. Signals are only the last step of the rail signaling job. Meaning, before open a signal to a train, we have to know a lot of things. Where are the trains? So we have every devices on the track for train location, track circuits, axle counters, these kind of things. We have, of course, the command and control systems with a lot of different kind of technologies. And with the input, we can use signal as output. Just to say, signaling is something like 15,000 different reference parts. So it's absolutely not only about signals, there's a lot of mechanical parts behind. Other opportunities, track, of course, quite well known, electrical power supply, and civil engineering. I won't talk about civil engineering in the following slides, but of course, we are interested in what can be done regarding bridges, tunnel, and all this kind of equipment. Okay. Okay. This point is very important to understand what we need from additive. Rail industry is a heavy industry, meaning we need huge investment, and it's very hard to make this investment profitable. Sometimes it's even not possible. And what it implies is that we have, for a single function, something between 2 to maybe 10 different generations of device for the same function. And some are very old, some are very new, some are currently in development, but we cannot afford to replace all devices at every new generation. It's far too costly, because of the cost of the price itself, but also because we have a lot of study to make when we change the parts. Wiring diagrams, these kind of things, it's very, very costly. And as a consequence, we have a lot of products at different stages of their life cycle. This is great news for additive because we are products under development and we can use additive for rapid prototyping, why not? We have quite new products and we can use additive for mass production, okay? We have in-service needs and we have obsolescence needs. And the main use currently identified is about obsolescence, mainly because for the newer products, we have already contracts. Sometimes we even do not have the intellectual property of the parts, meaning we have a supplier entitled to the part. It's his job to make the parts with respect to the certification we made on this part, okay? So it does not mean we are not interested in additive for newer parts. Of course we are, but it's something we make with our suppliers. So this is a key message for our suppliers. We are ready to speak about additive solution for existing parts, okay? But once again, main need for us, obsolescence, which is a well-known use case of additive, and I think you will agree with me to say this is not the best shot for additive, but nevertheless it's our use. With specific opportunities, of course. In particular, we can switch material quite easily, because for all parts, the constraint can be quite low. There is not a huge need to stick with existing material, so we have opportunities of this kind. Opportunity of design, but in the same time, we cannot afford to change the design from scratch. We have to usually to fit in assemblies, tight tolerances, this kind of thing. So there is a balance here. Sometimes it's great opportunities, and sometimes it can be more difficult. What is interesting also to share with you is that we have facilities in France. We have 5 facilities with a know-how on conventional manufacturing, machining especially. And this is a great advantage because we can do a lot of things internally. Okay, maybe a few points on how we handle the additive manufacturing given everything I said before. This is a huge program for SNCF Reseau with a few key points here. I don't have a lot of time, so I will try to stay on the main points here. First point is that we try to deal with additive without forgetting conventional manufacturing. Every time we have an issue, we compare, we challenge additive with conventional manufacturing, and reciprocally, we can challenge a conventional solution with an additive solution. So this is a very pragmatic approach. We do not try to find absolutely a solution for additive. It's only a tool among other tools. And okay, a lot of other points. What can be stressed here is that we are very open to partnership, and that's why we're here today, because there is a lot of work to do together. And especially as we have facilities, we can do some part of the process regarding machining, post-process. So there is different paths that we can find to produce the part with additive, with suppliers. We can make as-built part to suppliers and make the finishing part in our facilities. Okay, there is different kind of solution, and it's an opportunity for us to address our issues. Okay, a few insights on our technical investigation regarding polymer, and especially polymer powders. We have made a lot of work with multi-jet fusion for different kind of use case, mainly 2 low mechanical parts, so parts with low mechanical constraints. It works pretty well. And something very interesting is the upper left picture is about resistivity. There is a graph on the lower left showing a comparison between PA12 with multi-jet fusion, PA66GF30, and bakelite, which is the historical material for this kind of part. And you can see PA12 is 1 to 2 orders of magnitude better in resistivity no matter the humidity situation, no matter the temperature. Okay, this is only one part of all the investigation we made on PA12. We also have made some in-situ testing, and we have investigated the ability of the process to be repeatable and so on. This is the process management. What we need from here is to continue the work on polymer. Regarding the MGF technology, we need to go further into producibility, repeatability, predictability. There is quite a lot of issues to address. So PA12, our first need. We also want to go further regarding PA11, MGF still, but also selective laser sintering. We need to find, for our use case, we sometimes need a huge stiffness. And for the sake of stiffness, it can be very interesting to find composite solution. Maybe SLS, maybe continuous fiber. So we have a lot of work that we want to launch in the next weeks on this topic. And we also made some work, but maybe we will have question about this later. Okay. And new technology, of course. Regarding the metal part, we have made mainly indirect casting. Indirect casting usually stated as a low-hanging fruit for additive. It's not so easy. We've made quite a lot of testing to deploy parts on the field, something we have already made. As you can see, there is a lot of documentation on this process. It works quite well, but there still are some axes of work, and I will come to this later. We've made a few works on selective laser melting. It's the second part, mainly design-oriented. We've made comparison between topological optimization and generative design in order to find the best way for this consolidation. It's a consolidation of 8 machined parts in a single one for the motorization of a lever. Okay, once again, we can talk about it later if you want. Main issue with selective laser melting is the price. We need to be very efficient for the price because for obsolescence purpose, we usually have conventional alternatives. Even casting for 2 parts is an alternative. So we need to be very cost efficient to find the best solution. And as selective laser melting is very cost intensive, so we wanted to see what metal binder jetting can do. We've made some testing. There's a lot of potential, and once again, a lot of future work to do. On next steps. Next steps regarding indirect casting. Once again, we need. For industrialization, we need to have a better assessment of the sound mold to have better end part. Let's put this that way. For SLM, main point is to try to lower the cost. And one of the ways to do this, there are 2 ways maybe. First one, maybe find the good settings for our just need. Maybe we do not need the best settings for the best part. We can afford to have low mechanical characteristics, guaranteed, but low. And for this low mechanical characteristic, maybe we can have settings that are better for the cost. The layer height, maybe the speed, the laser speed, these kind of things, okay? And on the qualification also, maybe with monitoring, we need to lower the cost of every steps of production for this technology, at least for our purpose. Metal binder jetting, same thing. What we need here is to have a technology which answers our need, just our need, at the right price. And for metal binder jetting, a solution could be just to have parts that are not full dense, because we don't really need full density for our application, or not for every application. And in this case, maybe partial sintering, this kind of solution, infiltration, could allow us to have good geometrical tolerance and at a low price. So this is exactly the kind of solution we need. We're also interested in DED, but I have no time to talk to you about that. Okay, last slide, and then I will take your question. Okay, factors, what we need from the industry, how we think we can advance on the topic. I think you have understand, we need to be very cost efficient. We have great opportunities, but we need to find the right cost and the right quality. Quality is maybe not a good word. Behind quality, I mean producibility, repeatability, predictivity. And in order to find the good balance, the good cost, and this good quality, we need to work on the technology, fundamental knowledge. We have a lot of work going on this to really understand material properties and the link with parameters. We need to find accurate settings for our need, what we can accept, what are the consequences of the settings. We deeply believe in screening, design, and simulation to help us to do the right part from the first build. We cannot afford to make 10 builds before having a good part because this is absolutely not cost effective. We really need to be able to have a good idea of what will be the end part before producing it. And of course, it's the main point, we need an efficient industrial ecosystem. We have a lot of partners, a lot of very good partners in France and in Europe. And we need to deal with this topic with these partners in order to find solution. Okay, I think we have something like 3 minutes for any question if you have questions on the presentation.
Thank you, Pascal. Yes, if anyone has questions they would like to ask now, I can bring you the microphone. If not, you can catch Pascal after the presentation. Or how long will you be in Frankfurt at Formnext? You here all day?
No.
No.
You should catch me just after the presentation.
Okay. So in the medical sessions this morning, we heard again and again that post-processing of parts was a major, if not the major, hurdle in sort of true industrialization. Obviously, you've highlighted a lot of challenges with your applications. If you could find at Formnext one solution that you could take back to show everybody that would help on your pathway to industrialization, true industrialization, what would that be? What would be the
one solution in Formnext? Not about post-processing or globally speaking?
In any part of your process change.
Any part of the process. I've seen something very interesting regarding injection of continuous fibers. Injection of continuous fibers, I think it's quite intriguing. The idea being to have channels in your part, and you can inject the continuous fiber in the channels. So you can use 3D printing to make the channels in the direction you need. And injecting the continuous fibers, you can decide the fiber orientation. And I think it could be a game changer for the industry and for our need, because you can have polymer parts, and you can bring these polymer parts to your need of mechanical purpose with just the right need, just injecting the fiber where you need it, the right amount of fiber at the right price. And you use 3D for what it's good at, meaning make the channels where you need the channels. And you cannot do this with another technology.
Interesting. Okay, one to keep an eye out for. Pascal, thank you very much for your presentation.
Thank you.